All right, you guys, today we are taking on a little bit more practice with triangle congruence and CPCTC. So just a reminder that CPCTC stands for corresponding parts of congruent triangles are congruent. When we use it in proofs, we're using it one step beyond proving that the triangles are congruent. So if we know triangles are congruent, then we can link up any remaining pairs of sides or pairs of angles. Let me zoom in a little bit tighter. All right, so in the first proof, I am giving you that GA is the perpendicular bisector of RI. So I'm going to start with that given. So GA is the perpendicular bisector of RI. Given. All right, so GA is the perpendicular bisector of RI. So where does that lead me to? That leads me to a right angle here and a right angle here. That's what it means to be perpendicular. So I can say in step 2 that angle GNR is right, and angle ANI is also right. Okay, again, I'm building off that language of perpendicular. So I know that those angles are both right angles. That's what it means to be perpendicular. So definition of perpendicular. Now, I don't know if my proof is going to build towards using HL for the triangles being congruent. I don't know if I'm just trying to prove side angle side. I don't know. So what I need to do right now is I need to tether those angles together. So right now, since I've told you that they're both right, I can say, well, right angles are congruent. I could also argue that since those are vertical angles are congruent. So I have two places I could go here. I'm going to go ahead and say that angle GNR is congruent to ANI because of the definition of right angle. If you wanted to say vertical angles are congruent and cite the vertical angles theorem, that would be fine also. So it's another way to connect those two angles. So I know that those angles are right angles. I know that those angles are congruent angles as well. Okay, I have another given, so I'm going to throw that in here next. So here, oh, I'm sorry, I have one more thing to tie up with that one. So I also was told that GA is a perpendicular bisector of RI. So I've gotten my angle connection. I need to get my side connection out of it too. So if I know that GA is bisecting RI, then RI is being split into two congruent parts. So let me add that part right here, that RN is congruent to IN. And that's just building off the portion of this given that said bisect. So this would be definition of bisect. All right, so now that I have used that given, right, I've built off the perpendicular relationship, I've built off the bisect part as well, now I need to look at my other given. So I'm given that GR is congruent to AI. All right, given, and then mark the picture. All right, so here we go. Now when I look at my two triangles, do I have congruent triangles? And if I do, then can I go one more step beyond and say, well, if my triangles are congruent, then I can link up any other remaining pairs of sides or pairs of angles. So right now, looking at my picture, I can say, yes, those triangles, they have to be congruent. I have HL. So triangle GNR would be congruent to ANI. My reason would be HL. Okay, so now again, my proof is, can we connect these two angles? Can we say that G and A, those angles are congruent? And I can say again, yes, because my triangles are congruent, right? I've made these three connections, then any other remaining pairs of sides or pairs of angles, they have to be congruent as well. That is CPCTC. So I can reach my conclusion that angle G is congruent to angle A. CPCTC. Corresponding parts of congruent angle or congruent triangles are also congruent. So I'm linking up these angles directly after establishing that my two triangles are congruent. All right, let's do another one. B. All right, so here I want to eventually prove why it is that these two sides are congruent. So I'm going to have to first connect these two triangles first. So let's start with the given and see where it leads us. So KU bisects angle PUN. Given. All right, so this segment here bisects this angle. So that means that this angle is split into two congruent parts. So I can say that angle PUK is congruent to NUK. Right? That's what it means to bisect. Definition of bisect. If we bisect an angle, we split it into two congruent parts. All right, that given is a dead end now, so I'm going to pick up my other given, that angle 1 and 2 are congruent. So here and here. How do I build off of that relationship? Right now, I know that these two angles, they're outside of my triangles, and I have to work my way inside. So if I know that 1 and 2 are congruent, and I know that 1 and 3 form a linear pair, they have to be supplementary, so do 2 and 4, then I can connect the supplements of these congruent angles. So I have to first say that angle 1 and 3 are supplementary, and so are 2 and 4. I know that because they form a linear pair. So linear pair property. So right now, if I know that 1 and 2 are congruent, 1 and 3 are supplementary, so are 2 and 4, then I can get inside and connect the supplements of those congruent angles. So in step 5, I can say that angle 3 is congruent to angle 4. Congruent supplements theorem. Okay, so now I have two pairs of angles inside of my triangles that are linked up, and I need a pair of sides. I see that shared side, that common side right here, single tick mark. So I can say that UK is congruent to itself. The order stays the same here. The directionality stays the same. It is the reflexive property of congruence. So now that I'm here, I have two pairs of angles and one pair of sides. They are included. So I can reach the conclusion that my triangles have to be congruent. So triangle PUK would be congruent to triangle NUK. I have angle, side, angle. Okay, so now I've linked up my two triangles. I've shown how they have to be congruent. But in the end, I want these two segments to be congruent, here and here. So my reason for making that connection is, again, CPCTC. I know that if my triangles are identical, then I can link up any other remaining pairs of sides or pairs of angles. So I can reach that desired conclusion that PU is congruent to NU because of CPCTC. All right, let's do another one. All right, so in this proof, I'm giving you a pair of sides are both parallel and congruent. And I'm trying to build a proof that shows that the other pair of sides are parallel too. Okay, so let me start off with my given. I'm going to lump them together. I'm going to say, okay, MA is parallel to IL, also congruent. I could split them up. I can lump them together. It does not matter to me. I will put them together in this case, just like that, given. All right, where do those parallels lead me to? So I'm going to darken them, emphasize them, and then draw in a transversal. So I can see then that those parallels are going to lead me to these alternate interior angles. So angle MAL connects to ILA. So alternate interior angles theorem. All right, so I have one pair of sides, one pair of angles. If I connect that shared side right here, that's the reflexive property of congruence. So I can say that segment AL is congruent to LA. So AL to LA. Reflexive property of congruence. Okay, so now that I'm here, I can see that my two triangles, they have to be congruent, right? I have side, angle, side as my combination. So here in step 4, I can say that triangle MAL is congruent to ILA. Side, angle, side. All right, so now I'm trying to prove why is it that these pathways here and here, why is it that those pathways are running parallel? So I have a few options for what I can do, right? I want to remind you that if I know that a triangle, let's say that I focus on this triangle. So I know a triangle is congruent to another triangle. Remember that you can link up any other remaining pairs of corresponding sides or angles. So let's see how that's going to be helpful. Let me emphasize the parallels that I want to link up here and here. So which pair of angles should I use? Does it matter? Could I use these angles here? Yeah, because those would be alternate interior angles here and here. Okay, could I have used these ones? Yeah, I could have used those ones as well. I think that my instinct here is to use the alternate interior angle pair here and here. So that's what I'm going to go with. So when I mark them like that, I can see it clearly if that blue segment is my transversal. I can see how to make that connection with that pair of angles. So let me just draw it off to the side just to help you visualize it even more. So here I have these two pathways. This is my transversal. So could I now say, using CPCTC, that these angles match? Yes, because again, CPCTC. So I can say here next that angle MLA has to be congruent to IIAL. CPCTC. So I want to look at, again, the angles that are left and see which one's going to help me make a connection, right? I know that these two angles would have to be congruent CPCTC. So would these two angles. I just have to see which one is going to help me connect to say that I have parallel pathways here and here. So I saw that it was going to be these right here, because once I have those two angles in place, now I can use the converse of the alternate interior angles theorem to get to these pathways running parallel. So I can get to my conclusion right here and say that ML runs parallel to IA. My reason, step 6, would be the converse of the alternate interior angles theorem. All right, we have one more proof. All right, so in this one, we are given that this triangle, this big one, is isosceles. And we want to finish with this small one, also isosceles. So we know we're going to have to use triangle congruence somewhere in this proof, so let's get started. Let's look at that big triangle and see where, knowing that it's isosceles, where that's going to lead us. So triangle KCL is isosceles with a base KL given. Well, what does it mean to be isosceles? Well, it means that we have congruent sides here and here. So I can build off that. I can say that CK is congruent to CL. So if the triangle is isosceles, then we have two congruent sides. But I actually also know that I have two congruent base angles. So if this triangle is isosceles, I have these two sides that are congruent, and I have these two base angles that are also congruent. So it's another place where I can build off of my triangles being isosceles. So if this triangle is isosceles, then two congruent angles. So when we have isosceles triangles, right, sometimes we link up their sides and sometimes we link up their angles. And here we're doing both. All right, so I'm at a dead end, building off of that given, so I'm going to pick up the other given. Angle KCR is congruent to angle LCE, given. And then mark my picture, KCR. So this angle to this angle here. Okay, so I can see then that my triangles, they have to be congruent. Triangle KCR has to be congruent to LCE. I have angle side angle as my combination. So now what I have are these two congruent triangles. How does that lead me to this triangle here being isosceles? Well, this triangle would be isosceles if it has two congruent sides or if it has two congruent angles. So there's two ways I could approach it. The faster way is to say, well, if these triangles are congruent, then these sides are congruent, right? CPCTC. And if I have a triangle with two congruent sides, well, it has to be isosceles. So I could take that route. I could also say, well, if these two triangles are congruent, these two angles would have to be congruent, CPCTC. And then I could say, well, these are supplementary, so are these. And if I have two angles that are congruent and then two pairs of supplementary angles here and here, we could connect their supplements here and here. That would be the congruent supplements theorem. So it's just another path I could take. And then if I have two angles that are congruent, my triangle has to be isosceles. So I have two places to go with this. The easier way, I think, is what I said first. So right now, if my triangles are congruent, then I know that CR has to be congruent to CE. Here and here, right? That is CPCTC. All right, and now, since I have a triangle with two congruent sides, I can reach my conclusion that that triangle is isosceles. So triangle RCE is isosceles. So if a triangle has two congruent sides, then it is isosceles. All right, that's all I have for today. Have a good rest of your day.